All right, now we're going to look at how to find products of matrices or multiplying matrices. So the hint is in the dimensions, and the dimensions are row by column. So before we do anything, let's just get into the properties here. So we have three matrices, A, B, and C, and we have some scalar K. And I'm hoping what you'll notice is, okay, the associative property, there's no big surprise there. But the big one is this, and that's the distributive property. And what I've done is I'm looking at two pieces here, in which case they are equal, but in the center between them they are not equal. Okay? So what is it saying? It's just saying that if you multiply a matrix on the left, it must stay on the left. If you multiply a matrix on the right, it must stay on the right. And that has to do with the dimensions. Okay? So how do we find a product? Well, there has to be something about the dimensions. So what we're going to say is that if I have some matrix A and its dimensions are, let's say m by n, and we have another matrix B, and let's say its dimensions are n by p, then if we actually multiply these two together, these matrices together, we're going to get the product AB, and the dimensions are going to be m by p. Now maybe you see the pattern here, but in order for this to occur, the columns of the first matrix must match with the rows of the second. And you can clearly see that those are the same darn thing. What's left over, the m and the p, become the new dimensions for the product. Okay? This has to occur. If this doesn't occur, we're going to have problems. Okay? So let's just look at a nice example here. Let's just say that we have example 1. Let's just say what we have is A is, I don't know, 1, 0, 2, 1. Why not? And B, let's just say is, I don't know, a 1 and a 2. Okay? So we're going to start out with this, well, you know what, maybe we should start out with a little bit more typical. Let's just say 0 and negative 1. Okay, so I'll just change that there. In this case, it doesn't matter if we multiply A and B because the dimensions are all the same, 2 by 2s, which are kind of nice. So what we're going to do is we're going to find the product AB. Okay? So in order for us to uncover what this is, we're going to have to, first of all, see if the dimensions work for us. So I'm just going to rewrite it as 1, 0, 2, 1. And I'm going to multiply it by 1, 0, 2, negative 1. And the first one's dimensions are 2 by 2, and as we said before, they're all 2 by 2. So does this number match this number? Yep. So it can be done, and the answer that we're going to get, whatever it's going to be, will have to be whatever is remaining over, or the 2 by 2. Okay? So how do we multiply these out? Well, I'm going to draw it out a little bit here, and this is not the way I would do it. but I'm going to show you this way first. Okay, so here is the row by column method. Okay. And all I'm going to do is I'm going to work on this BC right here and do the product. So what we have to do in essence is multiply this row by that column. And we're going to have to do the same thing over here with this row and that column. So let me show you how it looks first. Okay. So it's going to be 1 times 1. So that would be the 1 times 1 plus the 0 times 2. So notice what we're multiplying. Okay, the first element by the second element in either the row or the column. Okay, now we'll just go over to the next one here, and we'll do that in, let's use red. So now what we have to do is we're going to go over to the 0 here now, and we're going to go 0 times this, sorry, not this number right here. So 0 times 0, so that would be 0 times 0, and then we're going to have to add it to 0 times -1, so that'd be 0 times -1. And now I'll just close this off here. And then we do the same thing. We go 2 times 1, so that would be 2 times 1 plus 1 times 2. And orange. And now we have to go and do the same thing, but now we're going to go 1 times 0 plus, oh, whoops, sorry, not 1, 2. That was my fault. That should be here. So 2 times 0, and then add 1 times -1. Okay. And that's the row and column method. Looks kind of messy to me. But let's actually put this down now and actually just do the calculations out. So 1 times 1 is 1 plus 0, and then we have 2, because 2 times 1, plus 2 times 1, and then we have 0 plus 0 up here, and then we have 0 and a -1 down here. So when we crunch all this together, it looks like we have 1, 0, 4, -1. All right, so hopefully you've seen the pattern here, here, and here, and here, and how they relate over to the matrices. Now, if you look very carefully, you might be able to see the pattern that we're going to use right now. And what we're going to do is we're going to call it the linear combination of the column method, and this is just an alternative way of looking at multiplying matrices. Now this is the same example. So what we're going to do is we're going to realize just a couple of things. What are the dimensions? Well, in the first one it's a 2 by 2, and the second it's a 2 by 2. We can perform the product of this because these are the same, and the end result is going to be what's left over, which is a 2 by 2. So whatever this is, it will be a 2 by 2. Okay. So here's the idea. And what I'm going to do is I'm going to pay close attention to this number right here, the number of columns. So that 2 is right here is the number of columns in the product. Okay? So what I'm going to do is I'm going to say column 1. And I'm also going to make another note, column 2, because there's going to be 2 columns in the product. So watch how I'm going to do this product. I'm going to take the first element of the second matrix and I'm going to multiply it by the first column. So I'm actually taking 1 of the first column, and then we're going to add 2 of the second column. So you see that was the second element. Now, let me go back up for a moment and show you something. Notice that we have 1, 1, 2, 2, 0, 1. If we look up here, we can go back and see 1 of this 1, 2. Do you see it? You see it? 1 of 1, 2, and 2 of 0, 1. Okay, so I'm going to leave that alone for a moment, and now let's use dark purple. And now I'm going to take the first element of the second column and multiply it by the first column vector. So this is 0 of 1, 2 plus, well, this is going to be a negative 1 of the secondary column, so that'll be a negative 1 of 0, 1. And now all we have to do is the scalar multiplication and then combine. So let's go back up to this first one here and realize that 1 times 1 is 1 and 1 times 2 is 2. And then we're going to add to it 2 times 0 and 2 times 1. And then we're going to add them together. So that's 1, right? 1 plus 0 is 1, 4. And let's do the other one here. And the first one just goes away, right? Because that's just 0. So all we're going to end up with is what? 0, negative 1. Now, all we have to do is now combine the columns. So we just take, let me do it in the right color here. So I use blue. So column 1 is going to go 1, 4, and column 2 is going to be 0, negative 1. And we are now done with the problem. And if we go back up, we can clearly see that we do have the same result. I'm not sure about what you think, but I think that linear combination of the columns well, what are they? They're linear combination of the columns, let's just say, best way to find products of matrices. And remember, we're going to use this later to solve this very equation for 2 by 2's.